All right, this is your 9-question review of algebra. Just as your homework for Monday night. And there's 9 questions. 4 of them are by modeling and 4 of them are by opposite operation. And one of them is just a vocabulary review. So your first question asks you to solve by modeling. And actually, it's probably not even a grade 8 question as much as it is a grade 7 question. So x negative 5 or x minus 5 is equal to negative 7. So the first thing we're going to do is get rid of our constant. That's the part of your algebraic expression that's on the side of the variable. There's our x. And it's your integer term. So there's our constant. And what we're going to do is we're going to add 5 to this side. And if we did, it would go like this, wouldn't it? So if we add 5 to one side, we have to add 5 to the other to keep it balanced. That's a 0 pair. I've isolated it just to x. And over here, those 5 and those 5 make nothing. I have a solution of x equals negative 2. And that makes sense because negative 2 take away 5 is negative 7. In our second question, we have negative 8 equals 4x plus 4. And we have negative 8 is equal to 4x plus 4. So the first thing we're going to do is find out what the constant is. And a lot of people think it's negative 8, but it's not because it's on the same side as the variable. So your constant is really this integer amount right here, positive 4. And we're going to subtract 4 from both sides by placing a negative 4 on both sides to create 0 pairs. When I do that, I'm left with this picture. And if 4x's, which is over here, is equal to negative 12, then each of these x's, if 4x is equal to negative 12, then each x would be equal to negative 3. I divide those x's onto 4 scales. And the solution to my equation is x has a value of negative 3, or x has a weight or a value of negative 3. If you wanted to check your answer, 4 times negative 3 is negative 12, and negative 12 plus 4 is negative 8, so the correct solution is negative 3. Our third question says solve by modeling again, so we're going to put our scale here to represent the equal sign, a balance of two sides. Negative 2 is equal to negative 1. Now this one here says a quarter of x. Now we could write it a quarter of x. We could write it a quarter of x, or we're going to write a quarter of x. Those are all the same thing. What we're going to write is x over 4. So a quarter of x, if the whole rectangle is x, that's a quarter of x. First thing I'm going to do in this two-step equation is get rid of my constant by adding 1 to both sides. When I do so, that's what's left over. Now, I don't want to know what a quarter of x is. I want to know what all of x is. So I'm going to quadruple this side. And the reason why I'm quadrupling this side is because these 4 parts of x, or these 4 quarters of x, when added together will make a full x. But if I quadruple the weight of one side, I must quadruple the weight of another side. And what I end up with is this beautiful full valued x equal to negative 4, and that's my solution. Negative 4 equals x, or x equals negative 4. Our final question in modeling says solve 3 groups of x minus 2 equals negative 6. Or you can read it as 3 multiplied by x minus 2 equals negative 6. I like saying 3 groups of x minus 2 equals negative 6 because it makes more sense. So the first thing I'm going to do is draw an x minus 2. Right? And this 3 that resides right here is actually saying I have 3 of those. So if I take this particular picture and I clone it, and then I clone it again, I have 3 groups of x minus 2. This here says 3 multiplied by x minus 2, or 3 groups of x minus 2. All right? Now 3 groups of x minus 2 is equal to negative 6. I'm going to put it as negative 6 here. And the reason why I spread my negative 6 out like that is because there are technically 2 ways to solve it. The first way is you could just add 6 to both sides. Right? Add 6 to both sides. And that keeps it balanced. But what it does is it gets rid of your constant. And actually, it inadvertently gets rid of all of your other side as well. So when I get rid of my constant of negative 6, I get that. And then I would have 3 x's is equal to nothing. So then each x, if I divide them into 3 scales, is also equal to nothing, or x equals 0. Now, I forgot to mention this. I should mention it right now. If I said to you, in this question. If I did a true-false question, I said true or false, the constant is -2. The answer would be false because the constant is not -2. We would have to expand it to see that it's actually -6 is your constant, right? So be careful of that, right? It's an important thing to know when you're dealing with it. Now, the other way I could have solved it by modeling is that if three groups of x minus 2 equals -6, and each group of x minus 2 is equal to -2. And what I essentially did is divide it into 3. So one group of x minus 2 is equal to -2. If I add 2 to both sides, I get x equals 0. Okay. Moving along. Our vocabulary. In this equation, what is the constant? The constant is your integer amount right there, which is +3. Your coefficient, remember what we talked about, if you drew it, it would be this, which is a -half of x, or -half of x. So your constant is -0.5, coefficient, excuse me. And your variable is just the letter, so x is called a variable. Right, the definition is x is called a variable. Use opposite operation to solve, so we're going to get rid of our constant first. Adding 3 to both sides, we'll get rid of the constant. You'll have 2x equals -1. Divide both sides by your coefficient of 2, and x will equal -1/2 or -0.5. Now, of course, when you get to this stage, what you would like to do is just take your -1, right? -1 divided by 2. If you didn't know it was a -1/2, that's one way to do it. But most of you know that -1/2 is a -1/2. Get rid of your constant first, +1 to both sides. We'll get rid of your -1. They're opposite operations, adding 1 and subtracting 1. A -3rd of x is equal to -2. So a -3rd of x would look like this as a drawing. And what we're going to do, another interpretation, is x divided by -3. The opposite operation is multiplying by -3. Those are opposite. If I multiplied a -3rd by a -3, I'd get a full x. And x equals a +6. Here we have distributive properties. Let's use op exp. Exp means expand, which means you need your expansion arrows. 3x's is 3x. 3 -5's is -15. Now we have a pretty simple algebra question. Add 15 to both sides. 3x equals 9. Divide both sides by 3. And x equals 3. And finally, use op div first, which means divide by each side first. So instead of saying -2 groups of x minus 1, I'm going to divide both sides by -2. Right? If I think about dividing both sides in half on the scale, or dividing both sides by -1/2, which doesn't really make a lot of sense, dividing by -2. But whatever I do to one side, if I do to the other, it maintains balance of equality. So instead of having -2 groups of x minus 1, I have one group. And 10 divided by -2 is -5. Add 1 to both sides, and x will equal -4.